Well, I'd like to thank all of you for coming to hear my presentation today. My name is Jesse, and I'm going to tell you about my capstone project in computer science. The project that I completed is a music composition version control software, and that's what we will be discussing today. So as I mentioned, this project is part of the requirements for completing the undergraduate course in software projects capstone. And as part of those projects, I had the privilege and opportunity to choose a project that I wanted to work on. So I met with my instructors, Alex and Dean, and we talked about what kind of options I would have. And I wanted to do something to do with music because that's my minor field of study, in addition to my major of computer science. So I was really hoping to do something to do with music, and they said that I would need to work with the music department in order to do that. So I consulted with a few people in the department and had the privilege of meeting Dr. Kyle Vanderberg, who agreed to sponsor me in the project. That's why I appear to be a team of one here, but I've had a lot of support from the departments. So next I'm going to talk about the objective of this software project. The objective of this project is to help composers of music track and view changes they make to their compositions in standard music notation. This project addresses a real problem and a real opportunity in the music world because composers of music need a way to organize their work process, and they need to have a central location to keep everything together. This project is also a really great exercise in software development, and I'll be outlining a lot of those details in the following slides here. So to start with, I've included just a little snippet of some music in standard notation. And this is kind of what the objective of the project is to give the music composer a software interface for viewing their music in this notation, as opposed to any other type of notation like text. It really has to be in this notation because that's kind of like a language for musicians, that any musician can see music in this notation and have at least some idea of what's going on in the music. And for those of you less familiar with music, this is just a simple three-state example with the treble clef and bass clef with some notes of varying duration and tone, as well as some lyrics. This example was submitted by Dr. Vanderberg himself. So the big question was, how are we going to implement this project? And what we decided to do was work with the Music XML format. Music XML extends a file format called XML, or Extensible Markup Language, which is kind of a multi-purpose programming language that describes how to store and display data. In this case, that data is music. So that's why we chose the Music XML. It's a standard and open file format for exchanging digital sheet music. And one of the reasons that it works so well for exchanging digital sheet music is that it's compatible with hundreds of different applications. So there's a great diversity of software out there already that uses this format, and that's why we wanted to plug into this this notation here for Music XML to sort of take advantage of that great compatibility. As for the software side, the project is located on a website on the internet, and they're located just a cloud service hosting company in order to host the software project on the internet. I've also included an example here of some music XML notation, and you might notice how much this contrasts with the common music notation example that I showed you earlier. As opposed to staves and lines and notes, instead we see a dizzying spiral of XML tags and variable names and attribute values. So I think that this illustration really shows the challenge in bridging that gap between music XML format and common music notation. So that's kind of the challenge here. We're trying to convert this into that nice, easy to read music common notation. And I'd like to tell you a few more details about the software platform that I implemented for this project. I chose a website on the internet because websites are already very cross-compatible. They're easy to pull up at a moment's notice from Mac computers, PCs, and a variety of different web browsers, Firefox, Chrome, Internet Explorer. It's pretty easy to access those from any location. There's also a very large code library for internet website development, and that makes it really easy to deploy. There's also an extra layer of security here too, because as opposed to an installable, executable program that the customer would have to install on their computer before they could even work with it at all, which would also open up some security vulnerabilities. This way, it's just a website that they can pull up right away, and they don't have to worry about installing anything or updating anything. It's just ready to go right away. And the programming languages that I'm working with here are just HTML, JavaScript, and PHP. Other options might have included Microsoft.NET or the Java platform. But considering that I already had some experience with these, and I've already developed some projects for corporate clients with these languages, I decided to work with those as a way to implement this project. And my sponsor fortunately agreed that that was a good way to develop the project. So the objective of this project, as I mentioned, is version control software. It helps composers of music manage different versions of their compositions. So we identified 3 different functions that will help composers do that. The first function is a file repository. That's a pretty basic element of every version control system. You need a place to store those files so that you can store each of those different versions. And the way that I implemented that was with a plugin called DropZone. I'll tell you a little bit more about that on the next slide. Another element that we're implementing to help composers manage their versions is with an engine to display that music in common music notation, and that's with an engine called OpenSheet Music Display. I'll show you an example of that here as well too. And finally, we also want the ability to compare differences between versions so that the composer can easily see what exactly has changed between those different versions. That turned out to be a good exercise in data parsing, and I'll tell you more about that in one of the next slides too. So going back to the uploading file process, that's with a free open source, freely licensed software called DropZone. I looked around for a few different uploading modules before settling on DropZone, but it was probably the easiest part of the project to implement. All I had to do was copy the source code from the website, which is freely licensed, and then configure a simple PHP script on the server side. And then it was pretty much ready to go. The only extra step after that was enabling write permissions in the folder that we're using to store that XML data. The next step was developing the music notation in the web browser. And as I mentioned, that's being accomplished with an engine called OpenSheet Music Display. OpenSheet Music Display renders the music XML with another software engine called VexFlow. And what that does is it just draws the musical elements, notes, measures, and so forth in the HTML5 canvas on the website, which is a relatively new innovation in web development, but it's proven very, very flexible and dynamic. Another reason that I chose OpenSheet Music Display was because it's very well documented. There was another one that I considered called ABC Web, but that one didn't have quite as good of documentation, and it also had some extra bells and whistles that seemed to distract from the music notation a little bit. So that's why we stuck with OpenSheet Music Display. And then, about halfway through the semester, we arrived at this problem of comparing differences between versions. And that was kind of like hitting a brick wall, because it turned out that there wasn't really any good engine out there already for comparing XML. I kind of thought that we would be able to tap into the parsing engine that works with web browsers, thinking that web browsers already parse XML in the HTML format. I thought it might be really easy to tap into that, but it turns out that those parsing functions aren't necessarily available at the web scripting development level. So that turned out to be a real challenge. And I spent much of the remainder of the semester working on that problem. So in order to begin working on that, first, I decided we need a list of what files have been uploaded to the website. But rather than just hard code a list as those files are added, I programmed a tiny little script in PHP that iterates through the uploads folder and creates that list in a menu on the fly, so that no matter when or how many files are added, the website can just display those options in a drop-down menu right away. The next step in comparing differences between versions is to load the XML file in the client-side JavaScript program. One of the earlier versions we had worked with was a comparison engine on the server side, but as it turned out, especially with these cloud hosting platforms, system resources are very limited. So they wouldn't actually allow the program all of the memory that it needed to do that comparison. So by switching to a client-side JavaScript program, it really opened a lot of doors into more complexity of analysis. And for those of you more familiar with programming, the object that does that in JavaScript is called the XML HTTP request object. What that does is it calls an asynchronous request to the server in order to pull back that XML data as a sequence or a string that's just serialized in a linear format. And that also solved another problem with the hierarchical nature of XML. As you might have noticed in that example with the music XML data there, there's a lot of different levels, and each level can have any number of elements, but it can actually be simplified into a simple linear sequence, and that made the parsing a lot easier. So how do we do that? How do we parse this complex XML data and turn it into something useful that we can manipulate? Well, the next step in that process is to separate the musical data from the formatting data. The music XML format includes data for describing the musical objects, and it has a lot of data for the formatting as a document on the screen. So the first step was just identifying which of those elements are interesting and meaningful. The ones that we identified for that purpose are outlined here. Part ID, measure number, step, octave, type, and text, which correlate approximately to instrument or voice. Measure number, that's exactly what it sounds like. Step is the tone or the frequency of the sound that the musician will be playing. Octave is part of that as well. Type is the duration of the musical note. And then text is a lyrical word, or what a voice would be singing. So I've included a little bit of the algorithmic description here. Depending on how much time we have, I could go into this in a lot more detail. The essential idea is to, in order to find those differences between versions, we also have to consider a number of different possibilities, because a simple linear comparison side by side would identify small differences between versions, but not necessarily larger changes like an insertion or a deletion of a measure before the change had happened. So what we arrived at is basically a measure by measure enumeration of each of the elements of interest that I mentioned in the previous slide. What that basically does is it compares every measure in one document with every measure in the second document. It identifies if every meaningful attribute, excluding formatting data, in the one measure in the one document is equal or not to every meaningful attribute in the first measure in the second document, and so on and so forth. And there's a whole lot more details that I'd be happy to talk about if anyone has more questions about that. But after it identifies what has changed between versions, then it just displays on the screen which measure numbers are different from the other version. So next I'd be happy to show you a demonstration of the website project. And just see if I can minimize this. So we'll start with the comparison here. Dr. Vandenberg provided 4 different versions of music that we can compare with here. the first two versions we got just had one difference between them, and the algorithm identifies that as a difference in part P1, measure 3. So if we click over to the display here, well, we can just click here. I can show you how that correlates with the display. So this is the first version. Let's look at part 1, measure 3, and you see that's a dotted half note C, compared with the second version he sent. And keep your eyes on it, because that's what's going to change here. And sure enough, that's the note that moved. And it's the only one out of this whole piece that changed between those two versions. So the algorithm is successful in that part. It just displays which measure number has changed, so that you can click over to the display and then see for yourself. There's also two more versions here, and these were a little more complicated. From March, looks like. So let's see what happens here. In the second two versions, we found differences in 10 different measures, but they're all in part P2, measures 13, 14, and so forth down here. And if you click over to these versions, well, they're not numbered, unfortunately, but those would correlate to the differences that have changed between those two versions. I can also show you the uploading page here. All this is tied together really with just a menu using the Bootstrap framework. It's a pretty simple navigation menu. Got a little information about the project and access to some of the documentation. So that's a little bit about how it works. And I think that's pretty much everything that we've accomplished so far. I think I'm really happy with the way that it's been going, and we've got that comparison pretty much nailed down so that it can identify differences between those versions, and then we can display that music and common music notation right here on the same website. So in conclusion, I'd just like to really thank the NDSU Computer Science Department for giving me the opportunity to work on this project. And I especially want to thank Dr. Kyle Vanderberg for being so generous with his time and sponsoring me with his time and guiding me through this software project. It's been a real privilege. Does anyone have any questions about the software project?
If you insert a measure, do you find that and claim it's only one measure that's different, or have you solved that problem?
Sort of have solved it, but kind of not. It turns out that in order to compare these differences, there's ultimately two different large arrays. There's one array for the first document and one array for the second document. Each of these arrays has a sequence of all of the measures and all of the parts in the music. So it's got just one big list of every part measure in the sequence. And then it iterates through each one of these arrays to identify which measures in the two different arrays have the same part identifier and the same measure number identifier. So from that's kind of the linear side-by-side comparison that I've shown you. In order to take that one step further and address the potential insertion or deletion of measures at some point in the music, then the program is going to compare the musical elements that were outlined in the previous slide here, each one of the notes and its duration, and identify the longest common sequence there. That's actually a recursive function. So first it identifies the longest common sequence between the two versions. Then it finds the differences and calls the function again on the second longest common sequences, and so on and so forth, which recursively identifies every difference between the two versions.
At one time you showed side by side. Is that still there?
Yeah. What I found was that it's actually easier just to copy the window pretty much. So you can open a new tab, open a new window, like so. So we'll display March 1st B with March 1st C, like so. And that's showing up pretty big on the screen here, so I'm going to resize that a little bit and just reload here. Oh, and I'm going to resize the window. Oh, is that going to work? There it is. And this way you can specify exactly, what dimensions. Oh, let's change both of them. And then you can just pick whichever version you want, like so. There might still be some room for juxtaposing those a little bit more in parallel.
So where it's at right now, though, when you find the first difference, does everything show up as a difference from there on? Or if there was an inserted?
If there was an insertion, in this algorithm, not quite yet. This one is pretty much just a linear algorithm. Fortunately, in all the versions that we've gotten so far, there aren't any of those insertions or deletions to handle yet. Well, if there aren't any more questions, just like to thank you again.
Thank you.